At this point, we've covered the 17 most common design patterns of the Gang of Four, 23 design patterns. Let's talk about the remaining design patterns that are not in such common use, starting with the abstract factory design pattern. This design pattern is essentially lets you create factories of factories. And you already know how factories work. And what they do is they let you create a customizable factory that then is used to create objects. And the idea being that you can customize your factory to create the kind of objects you want, and then just use the factory to create those objects. This abstract factory design pattern takes things a little bit farther, one step past that point, and allows you to create abstract factories. And the abstract factory is a factory of factories, really, and it's usually implemented as an abstract class, as a specification for factories, actually, and you can then extend the factory classes themselves from this abstract factory class. For example, let's make this more clear with a concrete example. You might have a need for a factory that creates objects. You might have a need for that factory on many different platforms, many different computing platforms. For example, Unix, Windows, Macintosh, and so forth. And so each of those has a different look and feel. So you might create an abstract factory and then implement the actual factories on those different machines, on those different platforms. Unix, Windows, and Macintosh, for example. And so the actual factory is different in their look and feel. They create the same kind of schematic objects, the same kind of designed objects on all of those platforms. However, the actual look and feel of the objects created by the factories match the individual platforms they're on. So you have the abstract factory, usually implemented as an abstract factory class, an abstract class. This abstract factory is used then or a specification for a factory is used to create different factories with. And this might be, for example, the factory for the Unix platform. This might be the factory for the Windows platform. So you have the abstract factory, then is used to create the actual factories. As I said, usually the abstract factory is an abstract class, is then extended in these various factory classes. Now you have two different factories, and this might be, as I was saying, this might be for Unix, the factory 1, factory 2 might be for Windows, for example. Then there will be a different look and feel, for example. You might want to have a different look and feel in Unix and Windows and the Macintosh. And then you use those factories to create various products, various objects, whatever you want to create with those factories, and product 1, product 2, product 3, and so forth. So you create different objects with these factories, and the idea is that you can have multiple types of factories across different platforms, and they might have a different look and feel, and the objects they create, the factories themselves are creating the same kind of objects. However, they share, in other words, the same kind of factory functionality as the abstract factory base class in which they are derived. So that's the idea behind an abstract factory. It takes the ideas of just normal factories one step farther, allows you to create an abstract factory class. So as you can see, this is an interesting design pattern. It's not going to be as in common use as the factory design pattern. However, if you have need for a more advanced use of factories, for example, factories across different platforms is one example. You might want to think about the abstract factory classes that you might want to create, and that is the abstract factory design pattern. Once again, the idea is that you use the abstract factory to create various factories with various object factories, and then you use those object factories to create the various objects you want to create. So that's the fundamental idea behind the abstract factory design pattern.